Good afternoon, everyone. So I am here today to present about our mathematical investigation on a certain problem with regards to numbers ending with 5. So first, I just want to share about my experience when I was in high school. So my teacher gave us problem about squaring numbers with 5. And the most interesting part is we need to solve it within 3 to 5 seconds without using a calculator. Just a mental calculation, just a little bit confused. Tracks me down, just like I was stuck for a moment. So now, I am going to share about how it works without using a calculator. You can do it also. Okay? Let's get started. First in the process is exploration. So let's explore the process of how the trick works. So first, give any number that ends with 5. So for example, we have 15, we have 25, 35, 85, 95, any number that ends with 5. But as of now, we are going to use 2-digit numbers first, okay? And then you multiply the number that precedes the 5 by the next number higher than it. So for example, in 15, so the first digit that precedes 5 is 1. So 1 should be multiplied with the next number higher than it. So it is the 2. 1 multiplied by 2, and that is equal to 2. And then tack on 25 to the end of the product. So the product is 2, and then you have to tack on 25 on it. So that will be 225. And you get the square of the number. That will be the answer, or the square of 15, 225. Let's investigate. So, second in the process is we have to gather and record data. So as you can see in my presentation, we have 5 squared to 55 squared. So 5 squared, it's obvious, right? We have 25. And then 15 squared, we have 225. And then 35 squared, we have 1225. And 55 squared, we have 3025. If we will continue the examples, if we will continue, the process will be the same. Okay? So for example, we have 85 squared, that will be 7,225, and then 95 squared, that will be 9,025. So for the step 3, we have to look for patterns, so how it works. Okay, let's do it. So for example, let's get this 3 numbers. 5 squared, so 5 squared is 25. Then 15 squared, we have 225. And then 25 squared, we have 625. Okay, now for patterns, as we can see all the numbers ends with 25 or 5. Okay, here is 25, here is 25 for the 2-digit numbers. In the first digit or 1 digit, we have 25. It's obvious, right? So for the patterns, let's get the 5 squared, the square of the last digit 5. So let's just put 25 directly to the end. And then to find the missing digits here, we have to multiply the preceding terms or the preceding number with a number higher than it, next number higher than it. So this is 1, this is 2. So 1 should be multiplied by 2, and the product is 2. You only have to put it here. And then 2 times 3. The next number higher than it is 3. So we have 2 times 3, and then we get 6. Now, for the step number 4, we have to make conjectures. Okay? So, to get the numbers or the square of the numbers, the first technique here is you have to only tack 25 at the end of the numbers. So any number that ends with 5, the square of the numbers should contain 25 in the end of the number. And then the preceding numbers before 5, we only have to multiply it by the next number higher than it. So for example, just like before, 15, so 1 multiplied by 2, because 2 is the next number higher than 1. And then you have to put it in the beginning of the square of the number. Okay? For the step number 5, we are going to gather more data and test our conjectures. We're going to apply it in 3-digit numbers, and for numbers wherein 5 is in the middle. Okay? Let's get started. So, for the step number 5, we are going to gather more data and test our conjectures. In the example, we are given 165 squared, 175 squared, 185 squared, and then 195 squared. So, 165 squared, we are going to multiply 16 by the next number higher than it. So, 16 times 17, we have 272. And then you have to tuck 25 in the end. So, that will be 27,225. And then for 175 squared, the same process, we are going to multiply 17 by the next number higher than it, and that will be 18. So 17 times 18 is equal to 306, and you have to tuck 25 in the end, so that will be 30,605. So for 185 squared, same process. So 18 times 19, we have 342, and then you have to tuck 25 in the end, so 34,225. And for 185 squared, that will be 38,025. So now we are going to apply it in 3-digit number wherein 5 is in the middle number. So for example, 156, 157, 158, and 159 squared. Okay? So for 156 squared, that is equal to 24,336. And then 157 squared, that is equal to 24,649. For 158 squared, that is equal to 24,964. And then for 159 squared, we have 25,281. For step number 6, we are going to revise our conjecture. With all the numbers ending with 5, the numbers or the square of the number will end with 25, and the preceding number or preceding digit will be the product of x times x plus 1. Okay? But it cannot be applied in the numbers wherein 5 is in the middle. Okay? So we are going to follow this simple step. So when the number 5 is in the middle, thus the product is equal to x squared. Then you have to put 2xy, and then you have to tack on y squared in the end. So x squared for the first digit containing 5. So any number that contains 5. And then 2xy will be added to the square of x. So 2xy will be added to the square of x. And then you have to square y for the last digit. Okay? Let's get some example. So for step number 7, we're going to verify our conjecture. See the examples in the presentation. So 150 squared will be 22,500. So 151 squared will be 22,801. And 152 squared will be 23,104. 250 squared will be 60,500. And then 251 squared, that will be 63,001. So 252 squared, that will be 63,504. 650 squared, that will be equal to 422,500. 651 squared will be 423,801. And lastly, 652 squared, that will be equal to 425,104. So how are we going to solve it? Can we apply the idea based on our first, or based on the exploration that we made? Okay, let's verify it. So to verify our conjecture, we have to find the process. So before, the process is x times x plus 1, and then you have to tack 25 in the end. So let's see if it works with numbers with the middle number 5. So 150 squared, that will be 15 times 16 is equal to 240, and then you are going to tack 25 in the end, and then solve it manually. So 150 squared is equal to 150 times 150. As we can see, 0, 0, and then 0, 5. So that will be 750, and then 0, 5, 1. So the answer will be 0, 0, 5 to 22,500. So it is not the same when we are going to use this process. Okay? So if we're going to use this, the answer will not be the same or will not be correct. So how it works? So the idea here is we have to follow a certain step. So for solving numbers with the middle number 5, we're going to use this formula stated and step number 4. So that will be x squared, then tac 2x y, then another y squared. So that will be our formula for solving numbers with the middle number 5. Let's see, for example, we have 157. So 157. So let us divide this into two terms. So this 15, that will be the numbers contains 5 or with the end of 5. So we are going to combine that, and that will be our x. Okay? So this 7, that will be our y. So following the rules or following the formula, 15, that will be squared. So 225. And then we have 2xy. So 2xy, that will be 2 times 15 times 7. So 15 times 7 is equal to 105. 105 times 2. So 2 times 105, we have 210. And then we are going to square 7. So that will be 49. So the answer will be 157 squared. The answer will be 24,649. Now, this is our clue. Okay? This is our clue. These three combined numbers is our clue. So, two to 5, and then we have 210, and then we have 49. So as we can see, 49 is here, but 225 is not equal to 246. So how did it come, or how it becomes 24,649 if we are having these three numbers? So this number, this middle number, will be added to x squared and be under the first digit of this number. Okay? The rule here is you have to put this last digit under the first digit of the number. So if we are going to combine that, that will be 225, and then 210, and then 49. Okay? So in writing in order, so we have 225. You have to add this two numbers to these two numbers. That will be plus 21 is equal to 46. 246.
Your phone's mobile data.
And then you have to tack 49. So 49. So this will be the number. Okay? That will be equal to the number. Right? So that will be the process in verifying our conjecture. So let's have another example. We have 158 squared. So 158 squared. 158 squared. So that will be same process. We have to square 15. So that will be 225. And we have to square 8. That will be 64. And then we have to 2xy. So 15 times 8. That will be 120. 120 times 2. We have 240. So 0 and then 4 and then 2. That is equal to 64. And then we have 9, 4, 2. So the number will be 24,964. Okay? Right? 24,964. So when we use the calculator, so that will be the answer. Conjecture, we have to use a calculator. So 158 times 158 is equal to 24,964. The same with this process, okay? So the next step will be discussed by Miss Regine Ortiz.
The next thing we're going to do is we're going to organize the data. If we are to square numbers ending with 5, the last digits should be 25. We have already discussed it to you, but let me show it again. The first example that we have is 45 square. We all know that the last digit should be 25. So how are we going to look for the other digits aside from 25? So we have given you a formula, x times x plus 1, to look for the other digits aside from 25. The x here represents this number, the first digit. So we have 4 times 4 plus 1 and 25. So which is equal to 4 plus 1 is equal to 5. 4 times 5 is 20. So thus we have 20 and copied 25. So 45 square is equal to 2025. The second example that we have is 55 square. Again, we have to repeat the process. So we have to copy x times x plus 1 and the 25 for this 5 square, which is equal to, the x is the digit before the 5. So we have 5 times 5 plus 1 and then the 25, which is equal to 5 plus 1 is 6. 5 times 6 is 30. So we have copy 30 and then copy the 25. So thus 55 square is equal to 3025. The third example that we have is 165 square. So we have to copy the formula x times x plus 1 and the 25. So the x here is the number before the 5. So we have 16. So the 16 times 16 plus 1, copy the 25, which is equal to 16 plus 1 is 17. 16 times 17 is 272. Copy the 25. So thus we have 165 square is equal to 27,225. The fourth example and the last example that we have for squaring numbers ending with 5 is 195 square. So copy x times x plus 1 in the 25. So thus the x here is the 19 before the 5. So that's 19 times 19 plus 1. Copy the 25, which is equal to 19 plus 1 is 20. 19 times 20 is 380. Copy the 25. So thus we have 195 square is equal to 38,025. On the other hand, if we are to square numbers where 5 is in the middle, we can get the product or the square by x squared, 2xy, and y squared. Let me show you. The first example that we have is 152 square. And we have to copy the formula that I said, x squared, 2xy, and y squared. So the x here, just like the previous video, the x here can contain one or more digits. So the x here is this one, 15. That does not contain the last digit. So which is equal to 15 square, 2 times 15. So what is the y? The last digit, this one, 2, is the y. And we have y square. So this is equal to 15 square is equal to 225. 15 times 2 is 30. And 30 times 2 is 60. And 2 square is 4. Now the deal here, what are we gonna do is that we copy 225 and we're gonna add 60 here, right here, and the 4. Did you follow? So we copy 225 and we added 60 right at the last and the first digit of the two, this one, the 5 and 6, and 0, and we added 4. So this is equal to 4, 0, 5 plus 6 is 11, 3, 2. Thus, 152 square is equal to 23,104. Now, the second example that we have is 251 square. So we have to copy the formula x squared, 2xy, and y squared. So the x here is the 25 because it does not contain 1. 25 square, 2 times 25, the x, and the y is the last digit, 1, and y squared. So now 25 square is, we can apply here what we have learned in the previous video. So we all know x times x plus 1 and the 25. So now the x here is the 2. So we have 2 times 2 plus 1, 25. So this is equal to 2 plus 1 is 3. 3 times 2 is 6. And 6, 2, 5. Now, 25 square is 625. And 25 times 1 is 25. Multiplied by 2, that is 50. And 1 squared is just 1. So, apply what we have done in the number 1. So, we have copy 625. And we're gonna add 50 right here. And the 1. So, that's 1, 0, add, we have 10, 3, 6. So thus 251 square is equal to 63,001. Now we have the third and the last example, 652 square. So now we are going to copy the formula x squared, 2xy, and y squared. So we know x squared here is this 165, and multiply x, which is 65, and the y, which is the last digit, 2, and the y squared. So now we are going to apply here what we have learned in the previous video. So we have x times x plus 1 into 25. So the x here is 6 because the 5 is the last digit. So 6 times 6 plus 1, 25. 6 plus 1 is 7. 6 times 7 is 42. Copy the 25. So now we have 65 square is equal to 4,225. So since we know that 4,225 is the square of 65, we're gonna copy it, and 65 times 2 is 130, and 130 times 2 is 260, and 2 square is 4. So now we're gonna copy 4,225. Now, what is going to happen here is, since this is a 3-digit, unlike the previous examples 1 and 2, we're gonna start adding here like that. Since it is a 3-digit number, so we're gonna add 4, 0, 11, 5, 2, 4. So thus 652 square right here is equal to 425,104. The next step is revise conjecture. Numbers ending with 5 can be squared easily using x times x plus 1 y squared. On the other hand, numbers where 5 is in the middle can be squared easily using the formula x squared 2xy y squared. Now we are going to verify our conjecture. So the first example we have is 95 square. So we're gonna apply what is in our conjecture. We have x times x plus 1 y squared. In this case, x is equal to 9. So we have 9 plus 1, and our y squared is the last digit, 5. 9 plus 1 is equal to 10, and 10 times 9 is equal to 90. 5 square is 25. So thus, 95 square is equal to 9,025. Our next example is 105 square. So we have to copy the formula. Our x here is 10 because it does not contain the last digit. And our y is 5, which is the last digit. 10 plus 1 is equal to 11. 10 times 11 is 110. 5 square is 25. So thus, 105 square is equal to 11,025. The third example is 395 square. So we have to copy the formula. Our x here is 39. 39 plus 1 and y squared is 5. 39 plus 1 is 40. 40 times 39 is 1,560. And 5 square is 25. So thus, it is equal to 395 square is equal to 156,025. The fourth and the last example that we have is 485 square. So we have to copy the formula. So our x here is 48. And our y is 5. So 48 plus 1 is 49. 49 times 48 is 2,352. 5 square is 25. So the answer is 485 square is equal to 235,225. Now we are going to verify our next conjecture. So we have the formula x squared 2xy y squared. So our x here is 75 square 2 times 75 and our y is 6 y squared. So in this part we can apply the first conjecture. So our x is 7 and our y is 5. 7 plus 1 is 8. 8 times 7 is 56. And 5 square is 25. So 75 square is equal to 5,625. So we have to copy. And then 75 times 6 is 450. Times 2 is 900. And 6 square is 36. So in this case, copy 5,625. So since our y square is 2 digits, so we have to cancel out 1 digit from 900. So it becomes 90. So 90 and copy 36. So we have to add 6, 3, 5, 11, 7, 5. So 756 square is equal to 571,536. Next example, we have 357 square. So copy the formula. X squared is 35 square. Y square is 7 square. So in this case, we can apply again the first conjecture. We have 3 is the x, 3. 3 plus 1 and our y is 5. 3 plus 1 is 4 times 3 is 12. 5 square is 25. So 35 square is equal to 1,225. I'm going to copy. 35 times 7 is 245. Times 2 is 490. And 7 square is 49. So in this case, we're going to do what we did in the first example. So we have to copy. Since this is 2 digits, so we're going to cancel out 1 digit. So it becomes 49, 49. So we're going to add this 9, 4, 5 plus 9 is 14, 6, 7, 2, 1. So 357 square is equal to 127,449. Our third example is 859 square. So we are going to copy the formula. So our x is 85. And our y is 9. So in this case, we can apply again our first conjecture. And our x here is 8. Eight plus 1 is 9. 8 times 9 is 72. And apply 5 square. So 85 square is equal to 7,225. Since we know it's 7,225, so we have 85. 85 times 9 is 765. Times 2, we have 1,530. Okay, let me show it. 9 square is 81. Since this is 2 digits, so we're gonna cancel out 1 digit here. So this becomes 7,225. Adding, since this is 3 digits, so we're gonna start adding here. And 81. So it becomes 81, 8, 7, 3, 7. Thus, 859 square is equal to 737,881. So now we have the last and the fourth example, 458 square. So we have to copy the formula. So our x here is 45. And our y is 8. So since 45, we can apply our first conjecture. So our x here is 4. So 4 plus 1 is 5. 5 times 4 is 25 square is 25. So 45 square is 2,025. So we have 45 times 8 is 360. Multiplied by 2, that is 720. And 8 square is 64. So we are going to copy 2025, 720, and 64. Since this is 2 digits, so we're gonna cancel out 1 digit here. So it becomes 2025 plus 7264. So this is 467902. So 458 square is equal to 209,764. In this part, we are going to extend the problem. So we have presented examples. We have 51 square, 52 square, 53 square, 54 square, and 55 square. So as you can observe, all of the numbers 5 are in the first digit. So what are we going to do with this problem? What are the formulas we're going to use? So next, we're going to have our conjecture. So for our conjecture, numbers that starts with the number 5 can be squared easily using the formula x squared plus y for the first digit and y squared for the last digit. In this part, we are going to check the examples that we have in the verify conjecture. So the first example that we have that we are going to check is 95 squared. So in our example or in our solution, the answer is 9025, which is correct. So the second example that we have is 105 squared, which is 11,025, also correct. So the next example that we have, the third one, is 395 squared. That is 156,025, correct. And the last example that we have for the first conjecture is 485 squared, which is 235,225, correct. So all our examples in the first conjecture are all correct. So now we're going to check the examples that we have or we solved in the second conjecture. So the first one is 756 squared. And that is equal to 571,536, correct. Next is 357 squared. And that is 127,449, correct. So the third one is 859 squared, which is equal to 737,881, correct. And the last one, the last example that we have is 485 squared, and that is equal to 458 squared, and that is equal to 209,764, which is also correct. So all of the examples that we have or we solved in the verify conjecture are all correct.